chaos engineering and continuous delivery. And SHOPKEEP firmly believes in the concept of sharing with the engineering world. We learn so much through other people, through Stack Overflow, through meetups, through Medium, and we feel we need to give back to the community. And so we host meetups, we deliver meetups, we share open source software. So we're happy to host this meetup. And if you have a story to tell, we'd love to help you tell it. So get in touch with me and we can help share that message. With that, I'm going to turn it over to Tyler from Audible, and he's going to take us through his stuff.
Thank you. All right. How's that? That's fairly close. All right. All right. Maybe we'll do this. All right. Yeah, this seems natural. Hey, how's it going, everyone? My name is Tyler Lund. I manage our core services team at Audible, specifically in the area of what we call consumption, which is not the Victorian era disease, but actually consuming Audible content. Whether it's on any of the apps that we're present in, any of the devices that you can listen on, like Alexa powered devices, or even like on our website. So we basically own all of the backend services for that. And I'll go into a little bit more kind of what exactly we own and how that's evolved kind of over the years. You can find me on Twitter and LinkedIn. My Twitter handle, I guess, is Tyler Poda. If you take nothing around chaos engineering around today, I will leave you with one llama fact. So Tylopoda is actually the Latin word for the, I think it's family or genus or something, of three-toed mammals, of which llamas are included. In a week from now, you'll a clap? Yeah, thank you. In a week from now, you'll remember that. Probably nothing about the rest of the talk. So we're actually here to talk about chaos engineering, not llamas. So I tried to get a little bit cute about names of what we're going to talk about. These are all books. This is a fun game you can play with yourself to try to guess what all these books are, I guess. So we're going to talk a little bit about how distributed architectures lead to complexity, which leads to chaos, which leads to the dark side when you're an engineer. We're going to explore a case of chaos at Audible, kind of how it came up, what happened, what we learned from it. We'll talk about what chaos actually is, and more importantly, what it is not. And then we'll walk through kind of how to implement chaos engineering and some of the lessons that we've learned along the way, kind of on our path to chaos. So most important thing, talk about me. I've been at Audible for about 6.5 years. I mentioned I manage our services for consumption. I've also worked on our website team and have done a little bit of work kind of around the app teams as well. Right now, our team is working on extending our content delivery globally, increasing the speeds and reliability of that, and adding access to a whole lot of new devices, largely in the Amazon voice area around the world as well. We're also consolidating our delivery and playback across all of these different surfaces, improving our quality on audio, which is really important as we kind of have grown as a business. We're less about audiobooks these days and more about all kind of spoken word content. We're doing a lot more original programming, expanding beyond just kind of our apps and more into the living room, cars, and other places where the quality of that audio really matters a lot. As part of Amazon, we're of course always looking at kind of the latest, greatest AWS stuff. We're have already kind of moved a bunch of things onto Lambdas. We're moving to a more event-based architecture across our services, and we're also kind of getting into exploring containers and AWS Fargate a little bit more these days, which is a really interesting area for us on the delivery side. I guess before I came to Audible, I worked in the financial industry on back-end order management systems, which our entire goal there was to reduce chaos as much as possible because you don't really want transactional systems to be chaotic. We didn't really have different QA or like ops teams there, So our team itself was really responsible for a lot of the quality pieces of it too. We didn't really have a name for it back then. I think maybe at best it was called like reliability engineering, but kind of realized all these years later that I was actually doing a little bit of chaos engineering there too. So I've kind of been around this for a while now, and kind of learned what to do and what not to do as part of it. And then lastly, I have to kind of throw in the pitch a little bit. My team is hiring. There are a lot of teams around Audible also hiring. We're kind of building the next generation of recommendations, improving our ordering, improving our apps, looking into things like progressive web apps. And we're hiring kind of across the board, SDEs of all levels, SDM, software development managers, technical program managers, product management, QA, really kind of across the board, both on the consumer-facing side and kind of more the internal business-facing roles. If you're interested, come talk to me. A few folks from Audible's recruiting team are here too, in the back. Aviv is there with his beautiful blue lanyard and eyes to match. That got weird a little bit. So we'll be around too. So I guess kind of before we get into this any deeper, who here is familiar with Audible? Who has heard of it before, this meetup? All right, good. How many of you are actually members? Okay, still, all right, less than I would have thought, but still pretty good. So I guess has anyone who has not used Audible actually listened to an audiobook before? Okay, a few people. Oh, actually more. Okay, cool. So our big thing obviously is audiobooks. Like I said, we're kind of getting into more content than just that. Going into more original programming. We're headquartered in Newark, New Jersey. It's a lovely, I think, 19-minute train ride across the river. But we also have offices kind of around the world. On the tech side, we've got a big team in Cambridge, Massachusetts. But most of our folks are kind of in Newark. We were founded back in 1995, which was way before the iPod, the iPhone, any other digital media devices, and acquired by Amazon in 2008. And that's around when we kind of started moving our platform to their ecosystem. We are the largest producer and retailer of audiobooks around the world. We have about 300,000 audiobooks and original content, includes bestsellers, channels, periodicals, radio plays, lots of things like that. Our content's in English, German, French, Japanese, Spanish, Italian, and a bunch of others. We work closely with a bevy of great narrators like celebrities. This is my coworker, Kate. This is Sam. He works down the hall. He's a little bit angry sometimes, but we work with him. Our content's across a whole lot of different areas. Some of them are things like children's books. As a father of twins that are about to turn 2, I definitely appreciate this one. We also have educational textbooks like science, chemistry, I guess dietary. And our mission itself is really to unleash the power of the spoken word around the world, whether that is audiobooks or not. This mission kind of started off way back in the day. This was Audible's original product, which was actually the very first portable media player, digital media player, way before iPod, your creative things and Diamond Rios and whatever. I'm dating myself because I had those things. I'm sure. So I think this held a whopping 5 megabytes of audio, which was not even enough for an entire book. So we've come a long way since. Since then, our members have listened to almost 3 billion hours last year. That is increasing all of the time, so we expect even more this year. And our average listening time is actually over 90 minutes, which is more than a lot of other media companies kind of in the video and like music space. So that kind of brings us to our talk about chaos. As we've grown all of these years, Audible, like I said, has been around for over 20 years. Systems become more complex, and they become chaotic as part of that. They eventually get to the point where no one can really understand every aspect of how everything works. There are so many different interactions and connections between different aspects of that system that it becomes unpredictable. When you start to have real-world events, your system may start breaking in ways that you never anticipated. So essentially, if you have a system of moderate complexity, it's already got chaos in it, whether you kind of realize it or not. So an example from our team, we own, like I said, the content delivery. So this is actually a greatly simplified architecture of how that delivery works. Each box here is representing kind of several other boxes further down, but try to simplify it to make it somewhat understandable. So essentially the way this works is when a user requests a download from their device, it goes to this content delivery engine. That gets some static metadata for the content. Our content delivery service, or CDS, gets a bunch of files from S3, calls our download service to check if the customer actually has rights to this piece of content before letting them listen to it. Those rights themselves are checked against a database. And then we also check a bunch of listening statistics in a Dynamo table to propagate their listening status of the book. So whether they've listened to 10% of it or 90%, we show that too. Before we kind of talk more about that and the problems that caused, this is Microservices 101, which hopefully many of you know, but I'll explain it anyway. So in a service-oriented architecture, basically we have a whole bunch of different services. All of them have their own individual responsibility. In this case, you have service A calls service B to get some sort of information. B ends up calling C, B calls D, C also calls D. You see how this quickly becomes complex and chaotic, right? For our specific example at Audible, on our website, we have on our homepage all of this content that we curate and show forth to the user. Some of it is recommendations, some of it is kind of curated by our merchandisers. But so we're basically getting all of this information from a wide range of services. I think across Audible we actually have over 100 different services. One of them is powering this curated books piece. When this isn't available, we don't want to just show an ugly 500 fail whale error. We want to gracefully degrade this so that our users can still find other content and actually listen to it. So that kind of shows here. So let's say service B is this curated summary service. It might be experiencing some high load or is just down right now, got broken by some bad deployment or something. So ideally what happens is service A detects that service B is down, realizes that and that it can still get the other information it needs from service C and D and shows some degraded experience with different content in that slot. So let's also kind of think about the customer experience in the app. What our customers actually care about is being able to buy a book and start listening to it as soon as possible, right? We want to kind of get out of their way after that point. They want to go into their app, immediately start downloading the content, get to this player, start listening. They don't want to see this horrible error that has like some ugly error code in it. They especially don't want to see this error, which doesn't even necessarily tell them what the problem is, that that service is down. Especially if that service itself is not like a core part of the experience of listening to this, right? So that brings us back here. So this is how we understood our architecture to work. It's what we thought for probably years. It's what we had on all of our wikis and documentation. What it turns out we missed is a little hard to see, but this box down here, this is the part where it actually checks an XML file to add some chapter information. That happens after getting the file, the audio file itself from S3, after all the rights checks, and after the database access. So if this part itself fails, we will give our service will give a 500 error. Clients don't really know how to interpret that, so they say, "Oh, an error. Let me try again right away." Even if they are intelligent about that and have like an exponential back off or only try once or twice, the users themselves see this generic error and say, oh, something is screwy, let me try again, let me hit the button again and again and again. So because of this architecture, which is especially bad, what that means is that they're accessing both of these databases, hitting S3, downloading like an enormous file, checking that XML file again when it fails, and basically just putting a huge load across all of these services, databases, S3, and the file store. And continuously doing that throughout the day. So we had that problem a while back, and essentially no one could download for nearly a day while we not only fixed the problem, but corrected the entire architecture piece of that to kind of recover from that error. That's how bad things got. So I guess, kind of things that we learned from that, and that brings us into the goals of chaos engineering itself. That was still, like I said, a dramatically simplified version of our download architecture. We don't know every aspect of it or all of the interactions. It is not humanly possible for a person to know all of that. We know that now. We accept it. We've learned that you really have to embrace chaos. Otherwise, you're just accepting that eventually things are going to break. You won't understand why. And your customers or users are going to find that chaos for you. And a lot of times that's going to be at 2 a.m. when you're on call and everyone else on your team is on vacation. So chaos engineering itself is the tool that we use to gain confidence in our systems and find these problems before our users find them for us. So the next 101 level part of the talk. So I think everyone's pretty familiar with how unit testing works. Essentially, we test code at the kind of component or module level. We provide some known input, verify the expected output, but this assumes that we know what that behavior is supposed to be for any given input, right? Integration testing, a little bit different, pretty similar. Basically, same idea, but we're testing at the system or service level, and we're still testing things that we know here. So with both of these, we can't test things that we don't know. Chaos engineering gives us a methodology and framework for testing those things. In chaos engineering, we call it experimentation rather than testing, since we don't know exactly how things are going to behave. And so we're running and designing these experiments to discover unknowns and gain confidence about how our system actually behaves. We might think we understand that behavior, but chaos engineering will help us find that based off of our hypothesis of how things actually behave. So specifically, what chaos engineering does is uses behavior like purposefully failing client calls between different services, introducing latency between those calls, simulating network or packet loss, or basically causing like resource contention issues. So, kind of going back on the other two types of testing, chaos engineering doesn't replace unit and integration testing. All three are, important parts of your test strategy. Chaos engineering just kind of gives you that next step on top of these, that a lot of places aren't doing yet. So one thing that I find a lot of resistance about in this is that, people say this is great for, media companies. If you guys cause a problem to your users, big deal, you fix it, their lives move on. I work in the financial industry or health or transportation. We can't afford any errors. But to that I say, we really should embrace it there. If you think about it, this kind of hypothesis-based experimentation actually originated in the health industry. It's how clinical trials are done. So basically already done there. And again, if you're not doing it with a purposeful methodology, you're basically just accepting that someone else is going to find the problem for you, and it's not going to be on your own terms. So kind of shift here to talking about how we actually implement chaos engineering. There's basically, I guess, 8 steps or so, kind of in the evolution of how we start performing these experiments. So first off, I call kind of socialization. This is when you are figuring out exactly what it is you're going to experiment on, and most importantly, communicating that and getting support from everyone else across your business. You want to get that help early on. A lesson we learned early on was that if you don't get that support, you are probably going to cause a lot of headaches and trauma for your team when people find out that you caused a problem that they weren't expecting. So definitely make sure you're kind of working across all of your different stakeholders to get their buy-in and support from. You don't want to go at this alone. The best way to get support is kind of find the other people that embrace experimentation and testing across your company. They're going to be great advocates for you as part of this. And really the best way to kind of get started here is to look at your recent problems and failures. We specifically use that giant download outage as a way to improve a bunch of our testing methodologies and tooling. I say kind of never let a good problem go to waste when that happens. The day that your CTO or CEO is coming to your desk and yelling at you about how things could possibly be broken for a day may not seem like the best time to tell him about chaos engineering, but it's actually the time that he's probably most going to listen to you. Good technique as part of that too is kind of show how chaos engineering is going to help you discover this type of inherent behavior and complexity within your system, and how you would have been able to detect it earlier, and also fix it faster as a result of it. Once you kind of get beyond that, you start to get buy-in. You want to define what your steady state is. Many teams don't think they have a steady state because they're always growing. I know our team doesn't really feel like we have a steady state a lot of the time, but that in itself is kind of a steady state. Your point here is to define what your system currently looks like, what the interaction is, and how much about it you actually think that you know. So a good way to kind of do that is work backward from how your users interact with the system. Think about what those experiences that they care most about are. Like I said, for us, it's downloading and listening. And then kind of think about what different components are at play as part of that. What are the dependencies, interactions? What things could break within that? You're not going to get everything right the first time. That's totally fine. Your point is you're forming a hypothesis around it and then going to start experimenting to validate that hypothesis. Good idea is also to start with kind of your non-critical services, or do it in like your QA environment or test or pre-prod, whatever it is you call it. That's just a good way to kind of build confidence in your tooling, your frameworks, your metrics, before you start doing it in your production environment and breaking things without knowing about it. Eventually, you definitely do want to do this in production. You're not going to find all of the issues that your real users will unless you're actually doing these experiments with real users. You eventually want to get there, but you don't necessarily have to start there. You don't want to force this down other teams' throats. Start kind of small level, minimize the blast radius, do it within your own team. If you know that your team is owns dependencies for other teams, make sure they're aware of it. Like I said, don't start running these and breaking things and they're on calls or freaking out because they don't know that you're doing this to them on purpose. Communicate widely, make it kind of a opt-in model rather than opt-out. Do it in the middle of the day when everyone's in the office. Don't wait until night and when everyone is left to do it. Eventually, you're also going to want to get to the point where you're not warning everyone about it, because you'll start to realize that the more often you do this, the more people get used to it and kind of do things around it that may prevent you from finding actual problems. So the thing that we saw was, when these events were planned, teams would purposefully not deploy services or make changes, for an hour or two beforehand, which kind of defeats the purpose because you want to find those things early on, right? To get started, you don't need to go to that level of kind of information hiding from them. So beyond that, then you want to make sure that monitoring is in place for all of this. This is really going to be kind of how your experiments live or die, how you'll know if your hypothesis is right or not. First you need to define what your key business metrics are. You may already have them. If you don't, a good way to think about it is what makes your users happy? What's their primary experience? What are the things that they want to do, and then have you get out of the way? Very important time to remember not to lose sight of all of your users. This experimentation is for their benefit. not the purpose of it is not to just break things for them all over the place to prove that your system doesn't have the right resilience. Never test something that you're not prepared to monitor or immediately fix. The entire point, again, is that you're finding these things, you have this monitoring in place so that you can find those problems quickly and react. So for my team, our key business metric, just to give you an idea, is playback starts per second. It's the kind of most critical experience for us. We want to make sure our listeners can actually start listening to things. Our kind of sibling team works on ordering. So for them, the add to carts or orders per second are their two most important. Our membership team, they care most about number of membership signups. So those are the things that they look at as their key business metric. So essentially, we know that if this key metric is healthy, then our entire system, for the most part, is healthy, and our customer experience is healthy. Other services, obviously, across our stack are important, but if they don't affect this, then they are less important. The important thing then that you're building out before you run the experiment is the ability to actually monitor that KPI. I think a lot of teams assume that they have the ability to do this, but realize once they start doing their first experiment, they have no idea what's actually going on. So you want to make sure you have really good tooling and dashboards around this. You're going to start off kind of watching this manually as you run the experiment, but over time you're going to automate this. Your chaos framework should be able to hook into this and actually watch your metric in real time. And if you're starting to see a negative impact to it, it'll stop the experiment. But we'll get to that. So once you've defined those things, you've kind of done the legwork for it. First type of experiments that you want to run are graceful degradation and restarts. You're starting off kind of small and easy here. These are things that can be started and stopped very quickly, done easily by hand. I mean, you're basically just killing a single host or restarting one of your services and kind of measuring the effect that has on your metric. This is really kind of just your basic check of your entire framework. You're making sure your metrics actually work and are somewhat real time, and that you are able to run these experiments in a controlled fashion and see what's going on. Another kind of principle to think about as you're doing this is what we call targeted chaos. Your principle here is don't harm other teams. Your entire purpose at this phase is to build support and kind of consensus across your entire organization. The worst thing you can do at this point is break a bunch of stuff and show that chaos engineering is disruptive to other teams. You want to show that your normal processes can kind of continue during this. Good way to do it is to do it with your team, like I said, or find a willing volunteer from another team that has services like this. Don't break things just to break them. You're validating your hypothesis at this point. And again, seek inspiration from your recent large issues to help kind of define those. After that, once you've kind of mastered all the basics, you're going to want to start causing cascading failures. So let me explain what that is first. Don't walk out right now and go back to your team and say, Tyler told me to cause massive cascading failures. Your point here is that you have your hypothesis defined. It's measurable with your KPI. For us, example was our hypothesis was that the listening statistics that we report from devices don't affect the ability to actually start playback. You're then running these experiments, doing something that affects other teams. So in this case, we brought down that listening statistics service and found that our hypothesis was incorrect, and it actually did affect playback start. But we were able to really quickly see that because we were watching that KPI, and we were able to immediately abort the experiment because we had the right metrics in place. So this is basically the phase where you're testing kind of your resiliency across all of your different services in your system. After that, it's kind of time to start getting fun with the different types of experiments that you run. Good basic one to do is start adding latency between all of your different services. Slow things down. We expect in distributed systems that latency of one call is not going to affect others, but a lot of times we find out that is not the case. Another one is kind of making your services and its dependencies unavailable. That could be, like I said, as simple as kind of shutting off some hosts, or maybe you want to kind of block authentication to them, or prevent network connections to them. Just to kind of see how your upstream systems handle that. Exceptions kind of between different services and calls, or even within services. We tend to forget about all of the exceptions that get thrown when we do unit and integration testing. I think a lot of times we strive for a test coverage number that tends to ignore a lot of the exception cases. So this is a good time to start actually validating that your exceptions handle the things that you think they're handling. We also like to simulate packet loss. It's kind of a really weird one that we don't really think about a lot as service engineers, because it's kind of abstracted from us. But a lot of times that abstraction layer actually does not handle that very well, and so things fail from that. We also simulate random amount of requests failing, see how that gets handled, if that affects other requests. And then another pretty easy to run one is resource contention. So that one you can just run some process that takes up 99% of the CPU on a host, see what happens. You can allocate all the memory on a host, steal all of the file descriptors or sockets and things like that, and see how resilient your system really is to that. After that, it's kind of time to start creating your own injection framework for this. Like I said, some of those things you can do a little bit manually. You can always SSH into a host and spike up the CPU, but eventually you're going to want to get to the point where you have this injection framework to help you start kind of automating some of these things. So this one is similar to what we use, but a little bit different. It's called Gremlins. It is a fairly widely used, commercially available chaos engineering automation framework. Amazon uses it. I think Netflix and a few other companies also use it. But basically, the idea here, it doesn't really matter which one you use as long as you kind of have some of these key capabilities here. So the key things that are you kind of see in the UI here are the ability to configure your experiments, or here they call attacks. I do like attacks. It sounds a little more menacing. You can monitor the ones that are running here. You can see your metrics and historical reports, and then you can even schedule future experiments to run. Kind of nice pieces about it, nice web UI. It also comes with the host agent that will go and do those things like spiking CPU and in memory. And then it also gives you a service framework, service injection framework. The way that works, you don't have to go buy one. You can build this yourself pretty easily. Basically, you want to inject a a plugin within your service that can intercept the calls between services and start adding these different experiments there. So this is where you're going to have things like your additional latency injected. I mean, it could be as simple as throwing in a sleep statement. I know we all like doing that. Or this might be where you start, throwing exceptions and failures within kind of this library. And then, you want to make this a library that you can kind of use across all of your services within that inter-service communication process that you have. After that, it's kind of time to really experiment the way that you're actually running the experiments. You will start kind of by defining what your maximum acceptable impact you can accept to the key metric is. Let me give an example to make that a little more obvious. So for us, we, going back to our playback event started, we decided that we could handle 2% of our users experiencing failures during these experiments if we were, actively monitoring it and could stop it quickly. So basically, that's the kind of thing that you're defining here. What is that maximum acceptable error rate that your metric can have? We then kind of plug that into our system. Our automation platform will spin up different control and experiment clusters, route traffic to each of those clusters based on the metric. It will then automatically monitor that metric, and if it breaches a certain threshold, start cutting off traffic to the experimental cluster, stop the experiment, and cut a ticket to us that we can then fix once we're all back in the office. It gives us time to figure out what the problem is, during our work hours and not in the middle of the night when we get paged. So this is kind of, how that sort of looks routing-wise. Sorry for the colors. We like using bright orange at Audible. This is kind of going back to that 2% traffic. So, we decided that 2% was acceptable. So we route 1% to this control cluster, 1% to the experiment one, and then measure that metric against the other one. The reason we do this rather than just kind of measuring the experiment against the existing production system is that, there's sometimes effects that you get just because of like a different balance of traffic. So by having exactly 1% of all requests go to control versus experiment, we're sure that those two systems are seeing the same overall behavior. So this is kind of what that metric measurement looks like. The orangish one is the control cluster. The gray one is the experiment. And so here basically we see around that point, our metric takes a nosedive. There's a pretty big discrepancy between the experiment and the control. So our system stops the experiment at that point. So once you have all of this in place, really the last thing that you want to get going is running chaos all of the time and everywhere. And I really mean that across your entire organization. Once you have automated these things and shown the benefits of it, you're going to start getting more and more support from other teams. They're all going to want to hop on this, and they can easily use your framework for this. I kind of hinted at this before, but we also suggest kind of running these experiments with limited warnings so that teams aren't cheating and preparing for it. Also strongly suggest running in production. Like I said, it's a good idea to kind of start them off in your development or test environment, but you want to automate it in production because you're only going to find all of the real problems by actually experiencing real world traffic. You want to run it often. Systems change all of the time. New dependencies get added, new services get added, and the results of whatever last experiment you ran kind of degrade over time. If you haven't run it in a few months or so, those results are pretty much no longer valid as to the state of your system. You no longer have that same level of confidence about how your system is behaving. It's a good time to also remember to get feedback from other teams and your stakeholders. Make sure that things are better than they were before you started running these experiments, and that you're actually solving the problems that your organization is seeing. If you're not solving those problems, you're probably running the wrong experiments. Kind of along with that, you want to publicize the results that you see from this. Talk about your big wins. What are the events that you've prevented from occurring again or for the first time? What did you find out with these experiments that you would have never found with simple integration tests or unit tests? What are the things that you were able to prevent because of that? Also totally fair to share the things that you didn't necessarily succeed with. Maybe you missed a few things that happened while you're running these experiments, and that's a good time to reflect and make sure that your experiments cover those. So kind of key things to take away from this. Every organization, in my opinion, should do chaos experiments. That chaos is already there in your system, whether you want to admit it or not. It's better to understand it than to wait for it to come up and bite you. The process of implementing chaos experimentation itself is very valuable for teams. It helps inform them about how their systems are working, and also kind of builds this good development culture of best practices that you otherwise may not have on your team. Kind of goes along with building up the DevOps or CI/CD type culture. Core tenet to remember through all of this is you're doing this for the benefit of your users. You don't want to harm them as part of this if you can control it. Make sure that you have all of those controls and metrics and things in place so that you're aware if you are causing that pain. And don't try to do this alone. Find your friends and fellow champions of chaos across your team, across your organization that can help you with this, even if they're not necessarily in your team. They'll be your biggest supporters and advocates through this. And remember, chaos doesn't cause problems, it helps reveal them. So that plus my llama fact at the beginning are the two things to remember. So let me stop there. I'm sure everyone has questions about, specifically how they might implement this in their organization. So I'm happy to take tons of questions. I think up here. Oh, sorry.
Have you ever tried or doing something like this with services like S3 being degraded, for example? So not something you control and obviously can influence, but other people's services.
Yeah, definitely. So we don't purposefully bring down like S3 or something to see how that would go. I suspect a lot of our friends on the Seattle side of things would not be so happy about that. But we, on our side of things, we will put up, purposeful latency or failures calling into S3 to see how our systems handle that and, how resilient they are to that type of thing. We learned that a few years ago when they were, S3 tended to be a little bit less reliable, I think. So yeah, we kind of do it. We do it on our side of things, but we do test systems that we don't control.
Can you elaborate a little bit on the that 2% graph that you had?
Mm-hmm.
So if you have a system with a bunch of dependencies, do you replicate that system and all their dependencies 3x, for instance, just for the experiment? And is that still considered production?
No. So good question. So we only replicate the specific service that we're specifically testing at that time. It's actually maybe something we want to do more in the future, where we would spin up more of a cluster. But a lot of these experiments that we're running are specifically targeted at one service, and so we only spin up clones of that service in order to run these. Because I think you could very quickly get into that the state where spinning up all of those other services and basically duplicating your production environment would make the experiment take a very long time to start up and run.
Gotcha. So in the case of a simple case of a web server and a shared database,
Mm-hmm.
you're not degrading the database itself. You're just degrading certain connections on a small subset of those web servers.
Yeah. So if we're specifically testing on the website side, yeah, we don't tend to do a lot kind of on the database side. It's much more kind of the upstream from that we run these experiments. So yeah, in that case, we're not touching the database at all, just the upstream either services or website. Sure. I think up here too.
I'm just curious about building out a chaos team. So I don't think it's prevalent enough that you can explicitly hire for chaos engineers, and you need a pretty unique skill set. Going all the way from having a testing methodology mindset, all the way down to knowing the low-level network information. So I guess when you're building out a team, is there a certain kind of background that gravitate towards chaos engineering? Do you look for a very technical QA? Do you look for DevOps that have a very testing-focused mindset or something along those lines?
Sure. Yeah. So we don't have a dedicated chaos team. Our team itself does a lot of this stuff, and we kind of put that onus on the developers on the team. I think things that I would specifically look for individuals that would be strong proponents of this is that kind of DevOps or test-driven kind of mindset. Some experience with test automation, CI/CD type stuff. But I think you're not going to find a lot of real-world experience with chaos. It's still a fairly new thing, and not a lot of places do it. So we don't explicitly look for that as a skill or anything. I think it's for us. We see it more as a team culture kind of thing that we try to grow and instill in people rather than explicitly find the advocates for that out in the world.
I guess is it more of an on-call rotation? Then when you have these experiments, someone has to come up with the idea, drive it forward, actually execute it. Is it like a rotation basis then? Is there a chaos champion in the organization, or?
No, so we don't have that specifically. I would say we have a few individuals that kind of do. So we do have an kind of IT ops team that is the kind of driving force between a lot of the force behind a lot of the load testing and experimentation that we do, but they're not specifically defining the experiments for us. We do that ourselves as a team because our theory is that we know the most about our systems and the important experiences for our users within those systems. So we're in the best position to think about kind of what the most relevant types of experiments to run are. But no, it's really more of kind of a grown from the team type of thing for us, not a top down type of thing. We don't. Yes, about on call too. So we tend to. I'm trying to think. So we don't exactly, or we don't have like a separate on call for these experiments or anything. It's just kind of our normal team on call. And so, we already kind of have the dashboards and monitors and things for our on call to detect problems as they occur in the real world. And so, like during these experiments, we just also kind of leverage those same metrics and alarms.
I had a question. How often do you run these experiments?
Well, that's a good question. Is it how often do we, or how often do I think we should? So we do. So I will say our organization is not fully at the end state of this. I'm not sure very many actually are. I think even across Amazon and like Netflix, who really pioneered a lot of this. They're at the level of a lot of that automation, but I don't think they've run it as often as they all would like to either. So I would suggest running it, like I said, very often, probably on a weekly or bi-weekly basis, because it kind of depends on what your velocity of changes within systems are. For us, just because there's kind of so much within our domain that those changes happen very fast. So we think that's probably the right cadence. But in reality, we really only run them about once a quarter or so. Doesn't make me happy, but we're trying to get there.
Every time I hear chaos engineering, as again, like I said, I'm working on an app, founder and director. So, my backend guy, backend web, he comes up with a lot of like bugs and things. I think he's running Angular, JS, whatever. So it's like there's a lot of problems. There's a lot of things that I have to deal with. So it's like chaos. Every time you said chaos engineering, I'm thinking of he's calling me, he's texting me, he's emailing me bad things. Now, having said that, is the big idea about like crisis management in essence? Is that what it is? Like,
I think in a way, I don't, I would say that chaos engineering works best for engineering teams where there's at least some stability around it. And it sounds like, early on enough that you don't have that stability. Yeah. But I do think, it's worth assessing if, some of this experimentation could help you find some of that instability earlier on in your process when it's less costly to fix, right? I don't know how much of that is your development team finding the problems versus your users finding them, but I would definitely say if it's your users finding those problems and getting reported to you, you want to, consider running these experiments so that you're finding them and fixing them before your users do, and potentially leaving your app and not coming back. Sure. Yeah.
Hi. How do you recommend running experiments if your user base is very small or like the weight on each user is very high?
That's a good question. I would say, I guess it may not necessarily be as big of a deal as you think for kind of running this. So, the problems that you're seeing, that your users are seeing, they don't necessarily, it doesn't matter to them how many other users are seeing that, right? If they're seeing a bad experience, that's kind of all that matters to them. So I would say, in your case, you may not define your kind of maximum acceptable impact as 1%, because that might be, only a handful of users or something. And it's not enough to get like a reliable metric around. So it might be like a substantially higher number, which is a little bit uncomfortable because then you're, potentially affecting them. I guess like in your organization, do you do any sort of like A/B testing or like experimentation of that type?
Not really at this moment.
Okay, because I think you'll kind of run into a similar problem there too, right? Like when you're doing, I think this is somewhat of an evolution of that type of testing, where A/B testing is a little bit more feature based, and this is reliability and experience based. But
Yeah, right now we just have things behind feature flags, and then we'll release features for a subset of users, and then see how that goes.
Okay, yeah. So I would say, like, use that kind of as your starting point. So if whatever it is you're comfortable releasing new features to a subset of, that might be, your starting point for how much of your user base you're willing to kind of run these experiments with, or maybe a little bit less than that. But if that number is enough that you feel that's a critical mass enough that you can get valid data from, then I think it's enough that you're going to get valid data from an experiment too.
Thank you.
Sure.
So, sorry. I'm curious, like when you're forming the hypothesis, how rigorous are you in defining the conditions that proves or disproves a hypothesis? Do you both have like a proven case and a disproven case? And also, I guess a subset of that is you're talking about effect of the business. Have you ever found, I don't know if you're running them enough at this point, where that kind of becomes an artful thing of getting those cases within the constraint of affecting the business metric?
So I think so on the hypothesis formation itself, I think you have to be fairly rigorous, maybe not to the level that you're talking about kind of with the both proven and disproven case, but you definitely need the proven case to be very strong. Maybe alternatively, the disproven case to be very strong, because you need to know if the experiment is failing or not, right? So I think you need a lot of rigor around, knowing exactly, if your hypothesis is that one of your metrics is not going to be affected by the experiment that you're running, that's fairly simple to define. That's basically the hypothesis. And if you see, and as a corollary, if you see the metric affected as a result of that, that is disproven, right? However, if you're doing something more like my theory or my hypothesis is that our listening statistics service doesn't affect playback starts. The ability to start playback, we may not actually have a strong metric to be able to measure that. And so in that case, you need to define, okay, well, I'm gonna, I need to see in my log that this line does not show up, or things like that. But I think it's kind of the same level that you should at least be defining in your acceptance criteria or definition of done of a lot of the development stories that you're doing. Some teams can get away with very little definition of those things, while others need a very strongly defined 20-page Word doc to define those things. So I think it kind of comes back to the culture and maturity, I guess, of the team, and how long they've been running this type of thing. I think we can kind of get away with a little bit less rigor around it because there are implicit assumptions that we can make just because we've done it for a while.
Yeah, appreciate it for the round two. Is there a point where you stop running these things? I guess, it's like an optimal level where you're like, no more, we're good, or just keep on sort of trying.
Do it forever.
Nope, just do.
Unless you're the only reason I would stop is if your system has stopped changing, but that is if that has happened, that's probably a bad sign for
Not a
your
good thing.
business. Yeah. Yep.
Any last questions? Okay. Well, thanks, Tyler.
Sure. Thanks all for coming out. I appreciate it. I hope it was interesting and get you on the righteous path of chaos. And if you have any one-on-one questions, I'll be hanging out for a while, and there's a few other Audible people here too. Yep. So be here.
And, thanks everybody for coming to Continuous Delivery NYC. Our next meetup is published. We'll be announcing it probably in the next few days. Lyft will be here in the middle of May to talk about immutable infrastructure. So if you're interested in that, come check us out. Also, if you have a story to tell, we'd love to help you tell it. Our dance card for the summer is starting to fill up already, with June and August tentatively penciled in. So get in touch with me either through Meetup or directly after the talk. Thanks.